Welcome to Basic Chemistry 1. The topic of this video is relative atomic mass and atomic mass unit. So let's start our topic. We know that the masses of individual atoms are extremely small, that is in grams and kilograms. They are in the range of 10 raised to power minus 24 grams to 10 raised to power minus 22 grams. Now, to measure such small masses of atoms, in first place, they are impossible in first place to measure and impractical to work with. So, what is the solution? Therefore, the masses of an individual atom of an element is measured by comparing its mass with the mass of an atom of another element, and that atom is taken as standard. And the reason for comparing the mass of one atom with the mass of another atom that is taken instead as standard are the reason why we measure the masses of atoms in such a way that we compare the mass of one atom with the mass of another atom or atom of another element. This we will discuss in the upcoming slide. The atom chosen nowadays as a standard atom is that of the carbon 12 isotope, the lightest isotope of the carbon, whose mass is admitted to be 12 atomic mass unit. So viewers, we well know that the unit of mass in our daily life or day-to-day life is kilogram. That is a standard mass with which other masses are compared when we want to measure some quantities. Here I have drawn a diagram to show you that how we measure something or take the mass of something. A physical balance is drawn here. So we can see that there is a weight of 1 kg, standard 1 kg, and another pane of the physical balance there is a sack, or you can say shopping bag, carrying sugar, and the mass of these two is equal. So we can say that the mass of this sugar that here is equal to 1 kg, and this is the here you can see the standard 1 kilogram mass. Similarly, now the question arises, what is the unit of mass for measuring the mass of an atom? So it is known as atomic mass unit, and it is defined as the mass equal to 1/12 the mass of one carbon atom is called one atomic mass unit, and it works for us in measuring the masses of individual atoms of elements as the standard kilogram works for us in daily life to take the mass of anything. 1/12 of the mass of one carbon atom is equal to 1 a.m.u, and this is working for us as a standard mass for measuring the masses of individual atoms. Now let us look at the definition of the relative atomic mass. So the mass of one atom of an element as compared to 1/12 the mass of one atom of carbon 12 C12 taken as 12 atomic mass unit is known as relative atomic mass. That is, the mass of an atom in comparison to the 1/12th part of the mass of one carbon 12 atom is known as relative atomic mass. How much is it? It is heavier than the 1/12th of the mass of the one carbon 12 atom. And 1/12th of the mass of one carbon atom is called atomic mass unit, as I have explained to you in previous slide that it is the standard and it is working for us in measuring the masses of atoms as we use 1 kilogram standard mass in our daily life. Here I have drawn an animation that had we been able to cut one C12 atom in 12 equal parts like this, here you can see that I have imaginary cut the carbon 12 atom into 12 equal parts. Now this one part, any one of these parts like this one, this will the mass of this part will be known as 1 a.m.u, and this will work for us in measuring the masses of atom is 1 kilogram standard mass works for us in our daily life to mass the measure of anything. And don't forget this, that this is a picture, an animated diagram, and worth at least $10,000. Here is another animation of how a.m.u is used as the mass of unit for measuring the relative atomic mass of an atom. I have drawn the diagram of a physical balance with two pens. In one pen I have put uh, the standard mass 1 a.m.u, you can see, and here it is lying one hydrogen atom and the two pens are balanced. So we can say that the mass of this hydrogen atom is 1 a.m.u. Now for helium you will need here 4 a.m.u's. 4 a.m.u's weights you will need to balance these two pens. So I can say that this is animation. It's not possible to take 1 a.m.u mass and make it as a standard and use the physical balance, but there are methods with scientists who can find out the mass of other elements by comparing it with one C12 atom, or we can say that 1 a.m.u standard mass. Now look at this slide. Here you can see here is an animation showing the relative atomic mass of helium atom to be equal to 4 a.m.u. In the physical balance, in one pen we have one helium atom. Here you can see, and in the other pen we have 4 a.m.u's. The standard mass is 4 a.m.u standard mass. So we can say that the mass of helium is equal to 4 a.m.u. That is how we take the masses of the relative atomic masses of atoms, and that is why we call them the relative atomic masses. Here are few examples of the relative atomic masses of different elements or atoms of different elements. For example, the relative atomic mass of hydrogen is 1.008 a.m.u, that of oxygen is 15.8994 a.m.u, chlorine 35.5, sodium 22.989, and so on. Here you can note one thing, that and in periodic table most of the elements have their relative atomic masses in decimal point, decimal fractions, not in whole number integers. What is the reason behind this? This we will discuss in another video or next video. The topic of that video will be average relative atomic mass or average atomic mass. So a little bit of discussion we can do over it, that we know that most of the elements have isotopes, and that is why we take the average atomic mass of these isotopes, and in periodic table we have the average atomic mass of all the isotopes of an element. So that is why these atomic masses in periodic table are not in whole numbers or whole number integers, they are in decimal fractions. Thank you for watching. Please don't forget to subscribe to my channel and click the bell icon for more updates. In next video we will discuss the ions and types. What is ion and what are the different types of ions. Thank you.